Okay, you ready? Here we go. Okay, so we're gonna talk about momentum today. And this is part of, Newton's third laws of motion, right? Third law of motion. Okay, so momentum, let's look right here. Here's people on carts right here, okay? Both carts experience the same strength and force, right? Because this person and this person are pushing against each other, and so, and they're gonna push off, right? They're gonna push each other off, okay? So, both carts experience the same strength and force, that's this right here, and that's Newton's law, part of Newton's law, third law. But the cart on the right experiences a greater change, in motion because it has less mass, right? And the question is why? Well, look right here. Remember, Newton's law of inertia, that's the first law, right? An object at rest is going to be at rest unless it's acted on by an unbalanced force. In other words, this cart right here, this cart's going to stay right here until I move it, right? I'm going to stop. Is the cart going to move? No. It says an object at rest is going to stay at rest unless it has an unbalanced force. And here's my unbalanced force right here. I'm acting on it, right? Okay. Okay, so Newton's law of inertia says object with more, but there's also the part of this that says object with more mass or more inertia have more reluctance to change their motion and vice versa, okay? Takes more power, right? If it's the bigger object is, that's part of that law. Okay, so also recall Newton's second law, and that says object with more mass accelerate less. Look here, there's more mass on this cart, right? So they're gonna go, it's gonna take more force to move them the same distance as what this person here's got less mass on that cart, right? Okay, so object with more mass accelerate less than object with less mass under the same force. These are the same force right here. This person and this person, they got the same force that they're pushing off from each other. Okay, makes sense so far? Okay, so how do we figure this stuff out here? Well, let's find out. Okay, so if we understand Newton's third law and momentum, we can predict how the motion of colliding objects will change. Okay? Momentum is the result of the mass of the objects. Momentum. P is momentum. Why didn't they put M? Why do you think they did? Why did they not use M here, Jaleel?
Huh?
Why didn't they use M in this? This is momentum. This is momentum equals. Why'd they write a P there?
That's what the. I don't know how
Well.
to pronounce it.
Huh?
I don't know how to pronounce it.
Well, look. If they couldn't use an M because you got M right here. What's M represent? Mass, right? And then V represents velocity. Remember that? That we could remember that from our 7th grade. We did energy of objects in motion, mass and velocity. Okay, so they had to use a P, right? So P means momentum. So momentum is the result of the mass of an object times the object's velocity. Here's the mass, here's the velocity. Okay, so momentum, that's in kilograms, or to meters per second. And then you got mass, mass is measured in grams, right? Kilograms. And then you got velocity is measured in meters per second. You remember that from 7th grade, Jaleel?
Yeah.
Okay, good. Okay, so you got a sheet of, here, I'm going to give you a card. I want to give you a card here. I want you to write this formula down. I want you to write the word momentum at top. I want you to write the word momentum at top. Write the word momentum at top. You're going to keep this in your folder. Write the word momentum at top. We're going to do a problem here in a second, so you'll have the formula, so you'll be able to give any answer. All right?
Right, momentum P.
Momentum. Write this word momentum right up here. Write momentum. And then below that, write P equals M times, Mr. Hughes, write M times V, right? M, these two letters together, that's in math, that means you multiply, right? Okay. Okay. You got that written down there, Terry?
Mhm.
Huh? You got momentum written at the top of that card, then you have this formula here, right? Momentum equals mass times volume. That's pretty simple, isn't it? Pretty simple formula. Everybody got this? You got this, Jaleel?
We write,
On your card. I gave you a card there.
yeah. I wrote it down.
Momentum, write the word momentum, then you write P equals
I did.
M times V, which is mass times velocity, right? Okay.
Mass times.
Okay, so this says find the momentum. We're gonna find that P right there. Of a skateboarder with a mass of 50 kilograms. There's our mass. Let's do this one together. So P equals, we got 50 kilograms, right? 50 kilograms. That's an ugly looking K, but it's a K, right? 50 kilograms traveling at, you can do it that way, times, there's several ways you can do this. 4 meters per second. And it says west, right? Cause that's what velocity, velocity is speed plus direction, right? Okay, so do you guys need a calculator to calculate this? Huh? What's 50 times 4?
50 times
50
4 is
times 400.
400.
What? Huh?
Is it 400?
50 times 4?
No.
It's like,
It's
50 times 4 is like 300 or something.
Let me see.
356, I think.
Calculate, 50 times 4.
It's 200. I got it right.
Okay.
Yes, yeah, 500.
Huh? Terry, you have a calculator? Give me a calculator. Okay, so 200 you say?
Yeah,
Okay, so what's our unit? What unit is it?
west.
Mr. Hughes, so if there's not nothing to drink, then what are we supposed to get water from? If you can't get nothing to water
Look
from?
right here. Okay, so here you are, right here. Here's what your units has to be. If we start out with kilograms, right, so 200 kilograms, write this down. Write this on your, you should write this problem on your, card that I just gave you. You can write it on the other side, that's fine. Write this on the other side, the formula. You got the formula, right? So now you're gonna write the problem. Okay? You don't have to worry about this, you don't have to worry about this little note right here that says, if you know the direction of the velocity, you also know the direction of the momentum. I'm gonna assume you know that, right? All I want you to do is write this from right here to here. And it's essentially what we wrote right here, right? Except for, so it's oh boy. So P equals 200 kg times 4 meters per second, right? And so P equals 200 kilograms, what? Kilogram miles per, or meters per second, and then west, right? Okay, that's our answer, there's our answer right there. There's our answer. Make sense? Don't worry about this right here. Don't even, we're not gonna worry about that, right, okay? We're gonna assume, that's an assumption there, we're gonna assume that's always gonna be correct. Everybody got this written down?
Yeah.
Okay, I'm gonna move on. Okay, we're getting there. Let's put our little box in here without breaking it if we can. Okay, so let's do another one here. Okay, so how can a small car, or small insect, I'm sorry, have the same momentum as a large car? Mark your answer, A, B, C, or D. Mark that on your document there. Mark this on your document, your CAMI document.
Oh, yeah.
Number 17, mark this and answer, okay?
Oh, okay.
How can a small insect have the same momentum as a large car? Is it because the insect has large speed? Is it because both the car and the insect are at rest? Is it because the insect has no mass? Well, the insect has some mass, so it can't be C, so it's A, B, or D. Okay, choose your answer. A, B, or D, choose your answer. How can a small insect have the same momentum as a large car? You're going down the highway. You ever gone down the highway at night with your headlights on, you get all these bugs on your window? Well, so how can a small insect have the same momentum as a large car? Insects have large speed, both car and insect are at rest, or insects has no mass. Oh, no, you can't choose C, I'm sorry.
Here.
A, B, or D, mark your answer. Which makes the most sense? Okay? Anybody need more time to answer that? Okay, let's move on here. Okay, okay, now here you're gonna have to do some math. You can do the math on your card there, okay? All I want you're gonna have to do the math on your card, right?
I remember these little calculators.
Or if you got a sheet of notebook paper, if there's not enough room. If you need, who needs paper? Hmm? Here, I got a little scratch pad here. Here we go. Here, do this problem on this little scratch pad. Okay? Do this on scratch pad here.
Do what?
Do this, I want you to do the math on the scratch pad here.
Triangle?
You're gonna have to do some math to get that problem, right? Remember P equals, mass times velocity? P equals mass times velocity. Remember that formula we just did? Okay, and then that way you're gonna be able to get, here's the formula, I'm gonna help you out just a little bit here. Here's your P equals mass times velocity, okay?
I got my answer.
Okay, and then choose your answer on your document there. Choose your answer on your document. Is it, are you gonna come up with, when you multiply 2 times 4, are you gonna come up with 3, 2, 8, or 8 kilogram meters per second, or 8 milligrams per second? Is it?
No, it's not. What powers?
Yeah, that should be an easy one for you. P, which represents momentum, equals mass times velocity, right? That makes sense? I gave you a calculator,
With these.
so you should take your calculator and multiply 2 times what?
4.
Okay, pretty simple, huh?
Mm-hmm.
Remember your units that you measure with. Lift your heads up, guys.
Yeah.
You guys, you can sleep when you go home tonight. Lift your heads up.
No, I'm not sleeping. I'm just.
I want you to lift your head up, okay? Okay. Okay, I'm gonna go to the next one. Okay, so let's talk about the law of conservation of momentum, okay? The law of conservation of momentum, and momentum is conserved, which means it remains the same. You remember what conservation means? That means you can't create it, you can't destroy it, it's always here, it's always gonna be here, it's just gonna change forms maybe, okay? That's what conservation means, law of conservation of momentum. Okay, that means, momentum is conserved, that means it remains the same during an interaction as long as the objects are not affected by the outside forces. And so this means that the total momentum of objects prior to hitting each other will equal the total momentum of the objects after the interaction. In other words, they're still going to have their momentum. Okay, so any momentum lost by one object is gained by the other one. So it's just changing from one object to the other, right? But still gonna be all that same momentum. That's the law of conservation of momentum. Okay? Kinda like the law of conservation of energy. You don't create energy, you don't destroy energy, you just cause it to change, right? Same thing here. Okay. Not gonna do that simulation. This law of conservation of, momentum, I'm gonna let you do this on your own later. Okay, I'm gonna move on here. Okay, let's look at number 19 here. Are you with me?
Yep.
Okay. Okay, so what two variables does momentum depend on? Mass and volume or mass and force? I'm sorry, mass and volume, mass and velocity, or mass and, force? You can't choose, B. A, C, or D, mark your answer. There's two things we've talked about when we talked about momentum so far, right?
Mm-hmm.
Okay, was it mass and volume, mass and velocity, or mass and force? Which of those three pairs did we talk about today?
If y'all get that wrong, I'm so just.
You're not gonna get it wrong. I have faith that you're gonna have the right answer. Okay? Are you with me, Michael? Okay, here we go. Everybody got an answer?
Mm-hmm.
Okay. Let's look right here. The total amount of momentum before and after a collision may vary. Is that a true statement or a false statement? Think about that law of conservation of momentum. The total amount of momentum before and after a collision may vary. The total amount, is it gonna be the same or is it gonna vary? So, this says it may vary. Is that a true statement or a false statement? Mark your answer. Don't blurt an answer, mark your answer. Okay. Everybody got an answer?
Mm-hmm.
I'm moving on. That should have been a pretty easy answer, wasn't it? Okay. Okay, we're not gonna, I'm not gonna show this to you online because whenever I, put this video on, YouTube, it would, reject the video because of copyright issues, so I can't show that. I think this is gonna conclude what we're gonna do today with this. At home, you can go, and just type in, a two-car collision simulator, and you should probably come up with, maybe even this one, but you should come up with something on the internet, okay? But I can't show it to you via YouTube because of copyright, yes, copyright laws, yeah. Okay, so we're gonna stop today, we're gonna stop right there today. Actually, that's gonna end this particular lesson here.